Okay, we're back. Hopefully you tried these problems, and now we're going to talk about it. So the first one says, Jack and Jill have finished conducting taste tests with 100 adults from their neighborhood. They found that 60 of them correctly identified the tap water. The data is displayed below. Are the events that a participant is male and the event that someone correctly identifies tap water independent? Okay, well, this is our test for independence. We need to test that the probability of A is equal to the probability of A given B is equal to the probability of A given not B. I'm going to create some notation. I'm going to call M, that means male. F is going to mean female. And I'm going to use the letter Y to basically mean that they identified it correctly, like as in, yes, correct. Okay, so let's start by finding our probability of M, because we want to see is M and Y, are they independent events? There are 35 males out of 100 people in the sample, so our probability of male is 0.35. Okay, now we're going to find the probability of M given Y. It's the next part of our test. Okay, I'm going to restrict my view to just this column. So the probability of male given they identified the tap water correctly is 21 out of 60. Which just so happens to also be 0.35. So we're on a good track so far. We have one last thing to check, which is we need to check that the probability of male given not Y is also 35%. So this time we're going to be looking at this column and see that male out of this condition that they did not identify the tap water correctly is 14 out of 40, which is also 0.35. So hopefully you said, yes, they are independent. Okay, Jack and Jill and their ability to identify tap water, done. 2 is a little bit more interesting, I think. It says the U.S. unemployment rate for July 2021 was 9%. What is the probability that nobody had a job from 5 randomly selected Americans? Okay, randomly selected Americans are independent. So, if I want to find whether the 5 people are unemployed, just whether the next person has a job is independent of the last. So, I can just take 0.09 times 0.09 times 0.09 times 0.09 times 0.09, or if I'm a lazy mathematician, which I am, basically what I'm finding is 0.09 to the power of 5, which is quite a small number. Let's see, 0, 0, 0. Well, this should practically be written in scientific notation. 0.05905. Okay. What is the probability that everybody had a job from 5 randomly selected Americans? Well, if the probability that I'm unemployed is 9%, then the probability that I do have a job is 91% to the power of 5. It's going to give me 0.624. What is the probability that at least one person had a job from 5 randomly selected Americans? Okay, what is the probability that at least one has a job? Okay, these at least problems are tough because at least one means, okay, either one person or 2 or 3 or 4 or 5. So I'd have to go through and calculate all those probabilities. Easier let's find 1 minus the probability that none of them have a job out of 5. So I need to find 1 minus 0.9 to the power of 5, which is 0.9999994. Pretty likely. Last one. What is the probability that everybody had a job from 15 randomly selected Americans? Okay, again, my probability of having a job is 91%, but now it's to the power of 15, and we get 0.243. Okay, number 3 says, an automobile manufacturer buys computer chips from a supplier. The supplier sends a shipment containing 5% defective chips. Each chip chosen from this set shipment has a probability of 5% of being defective, and each automobile uses 12 chips selected independently. What is the probability that all 12 chips will work perfectly? Okay, so if my probability of being defective is 5%, that means there is a 95% chance that the chips do work perfectly. And I need all 12 of them to be working perfectly. So this should be 0.54. Okay, number 4 says, the IRS reports that among all taxpayers audited, 70% end up owing more money. One new auditor randomly selected 12 tax returns, audited them, and boasted that he collected additional taxes from all of them. What is the probability of accomplishing this feat? Okay, 70% of people owe more money. This guy says out of 12 tax returns, all of them owed more money. So we have a 70% chance, and it needs to come true 12 times, 0.7 to the power of 12. So we should get 0.0138. What is the probability that actually none of them owed money? Well, the probability that they don't owe money is 30%. That's a chance that they did not owe money. And we need all 12 of them to not owe money. So again, we're going to get a very small number here. 0, 0, 0, 0, 0, 0, 5, 3, 1. Okay, how did you do on those? Hopefully well. This is why last class when we saw that problem where we had raised something to the power of 4 and everyone was looking at me funny, that's why I said we're going to learn that in 4.5 stuff. Okay, again, I'm going to end this video now, and this time I want you to try 5 and 6. 6 is kind of a challenging one, folks. Really think about it. Draw a picture maybe. Draw some kind of diagram to keep track of the things that are going on, and I'll be back with you in the next video.